Good morning and welcome back to Dr. Logic Awkwardly Does Logic in her office. Today I would like to talk about proof theory. We said a number of videos ago that every logical system that we'll be looking at has three components. A language, which tells us what are the kind of grammatical sentences of the logical system. The semantics, which tells us what these sentences mean. And now we've reached the third part, which is the proof theory, which is a method for taking propositions in the language and converting them into other propositions of the language in a way that is truth preserving. So this is the proof theory is a way of developing arguments that are, and we will show that this will be the case, good arguments according to the semantics. So semantics and proof theory work in concert with each other. We will define our proof theory so that in a sense it tracks our semantics. So when we are coming up with transformation rules to say if you have a sentence that looks like this, you can turn it into a sentence that looks like this, what's going to be underpinning these rules is going to be our semantics. However, you don't have to have the semantics in order to be able to deal with the proofs. So one thing that we talked about in a couple videos ago when we were talking about good syllogisms was this idea that in order to show that a syllogism is good, you would have to show that there is no interpretation that makes the premises true and the conclusion false. Now, there are infinitely many interpretations out there, and we don't want to have to look at them one by one. Instead, with the introduction of the proof theory, what we can do is we can give a proof that takes a particular syllogism, applies transformation rules to the propositions in it, and brings us to another syllogism, one that we know is already a good syllogism. So that is kind of the background of what it is that we are going to do. Speaking a little bit more specifically in terms of the syllogistics, so when I introduce proof theories for some of the other systems in later videos, things will be a little bit different, but the general idea is that we're going to have some sets of statements or arguments that we just take as good by fiat. So these are the axioms. These are the things that are in need of no proof and which are the foundations of our systems of proof or systems of derivation. Without this foundation, we wouldn't be able to get started at all. There will always be assumptions at the base of what we are proving. And then we will have a list of transformation rules that we can use to take these initial syllogisms and convert them into other ones. Later on, we will talk about our choice of rules and why these are good rules. But for the time being, just think of it in terms of the set of kind of obviously good starting blocks, which are axioms, and then we have our rules of proof, which will include rules that transform categorical propositions into other categorical propositions. If then we can come up with a derivation or a proof, and don't worry, I will define what that is in a little bit, but if we can come up with a derivation or a proof for every single valid syllogism, and then if we can come up with either a counterexample to all of the other invalid syllogisms, so that is an interpretation that makes the premises true and the conclusion false, or we can show that none of the invalid syllogisms can be proved using the system of proof that we have developed, then we will ultimately end up with a sound and complete system of reasoning for the syllogistic. So this is just a bit of background, saying some general things about proof theories, which will be relevant for when we introduce other proof systems for other logics, but also some specific things, but still kind of general hand-wavy stuff for the syllogistic. In the next video, I will start getting into the nitty-gritty details. I will tell you what our axioms are. I will start identifying various rules of proof, and I will show you how to put them together and end up with something that we can call a proof. So I look forward to seeing you then. Cheers.